Welcome back. Hearty welcome to you. In this session, let's try to solve this interesting example related to equation of straight lines. We have been given line L has intercepts A and B on the axis of coordinate axis. If the axes are rotated by a given angle, keeping the origin fixed, the same line makes intercepts of P and Q. Prove that 1 by a square plus 1 by b square equal to 1 by p square plus 1 by q square. So let's try to understand this by drawing the graph and see what they are saying. They are saying that there is a line which is making intercepts a and b, that is perfectly fine. It's making intercepts with the coordinate axis. Now the coordinate axis are rotated by an angle. At that time the intercepts became P and Q with the new coordinate axis. Now we have to prove that 1 by a square plus 1 by b square equal to 1 by p square plus 1 by q square. For that, first we'll try to draw the diagram. What we will do, we'll take a simple graph. We will put there x-axis and y-axis. This is our x and this is y. There is a line. We will draw the line. Before that, what they told us, keeping the origin fixed, the coordinate axes are rotated. So let me say this is that is the new coordinate axis. Let me just take a small angle. Let us say that way. We have to make a 90 degrees angle. So that will be 90 degrees. Okay, let us say that's 90 degrees. Now this is our new coordinate axis. This is x dash and that is y dash. Okay. Now there is a line. So let's draw the line. How the line looks like. Let's put the line. Let us say the line is, that's the line we have. Okay. Now if you take x and y, this point is nothing but a comma 0, because this intercept is a, and this point is nothing but 0 comma b. You know that if a line is making an intercepts of a and b on coordinate axis, then its equation is given by x by a plus y by b is equal to 1. Okay, right. Now when the coordinate axes are rotated by an angle alpha, if this angle is alpha, then now the new intercepts are p and q. What's the meaning of that? The meaning of that is this length is p. This length is p and that length to that point is q. I hope you are okay with that. So that is point q and this is point p. That is point p and this is point q. Okay, right. So now we have to prove that 1 by a square plus 1 by b square equal to 1 by p square plus 1 by q square. What is the approach we are taking to solve this problem? We will leverage the first condition given. Line L has intercepts a and b on the axis of coordinate axis. That means the equation of the line is given by this. Tells me that the equation of the line is nothing but x by a plus y by b equal to 1. Now when these coordinate axes are rotated by an angle, this line is getting 2 more points. So we will try to identify those 2 points. What are the coordinates of that points? Let us say those points are, let us say that is capital P and capital Q. We'll find out what is capital P and we'll find out what is capital Q. That's capital Q. We'll find out what is capital P, capital Q. Then after that we'll substitute that in the equation x by a plus y by b equal to 1. We should be able to solve it. Before that, what I will do, since this seems to be a little bit confusing, we'll try to magnify this and see how this looks like one by one. Let us take this first part now. We are focusing on this triangle. How the triangle looks like. we have x-axis. Then afterwards we have a line, that's the line, and we are interested now to get the coordinates of this point. That means I want to find out what are these x and y, right? So what I will do for that is I'll drop a perpendicular. We know that this is P, and we also know that this angle is alpha. Now what is the coordinates of this capital P? That is what we have to find out. So we will know that if that is P, then this length will be P cos alpha and this length will be P sin alpha. I hope you are okay with that. A little bit of trigonometry. So we know the coordinates of P are P cos alpha comma P sin alpha. So this part is taken care. Now let's go to the other side. Where is the point here? Capital Q. The point is here, capital Q, and we also have that it goes till down, and we know that length is nothing but equal to capital Q. Sorry, Q, that's the lower case of Q. This is what it is. We want to find out its x and y coordinates. So what we will do now, we'll just drop perpendiculars. If you drop perpendiculars, what is the angle? What about this angle? This angle is nothing but equal to 90 minus alpha. How we know that? We will check that 1 minute. So we know that that angle is equal to 90 minus alpha. How? If this angle is alpha, then the remaining angle here will be 90 minus alpha. If that is 90 minus alpha, then this small angle will be again alpha. That means this angle is 90 minus alpha. Why? Because always between x and y axis the angle is 90 degrees. If one angle is alpha, then the other should be 90 minus alpha. So by that you can understand that this angle is 90 minus alpha, what it is making with x and y. So this is what we are trying to construct here. Okay. Now we have to find out what is the horizontal and vertical distance. That means x coordinate and y coordinate. You can see that x is negative here and y is positive. Here both of them are positive. Okay. So what will be the coordinates now? If you see, this coordinate will become minus q sin alpha and this will become q cos alpha. Can you tell me how? Because sin of 90 minus alpha equal to this value divided by q, or sin of 90 minus alpha is cos alpha. So this is q cos alpha. So this should be q sin alpha. Only the thing is x is negative. So this becomes minus q sin alpha comma q cos alpha. So my coordinates are, let me just put down those coordinates. The coordinates becomes now minus q sin alpha comma q cos alpha. I hope you are okay with that. So what we found out is very simple. We know a comma b are intercepts when it is x and y coordinate axis. Now we rotated the angle by alpha. The new intercepts are p comma q. So now we have converted those points which are lying on the line when the angles are rotated, okay, are those intercepts. We, based on the p and q intercept, how to find out the point coordinates of x coordinate and y coordinate of those 2 points, that is capital P and capital Q. That we have found out. This is nothing but capital Q. So we know the coordinates of P are P cos alpha comma P sin alpha, and the coordinates of Q are minus Q sin alpha and Q cos alpha. Now we will try to leverage this equation, x by a plus y by b equal to 1, and these 2 points P and Q should be points on the line. So we will leverage that particular property and we'll try to solve it. So let's go to the next step. What we will write down now, substituting P cos alpha comma P sin alpha, we have P cos alpha by a plus P sin alpha by b equal to 1. Similarly, if we substitute Q point inside the equation, we will have minus q sin alpha by a plus q cos alpha by b is equal to 1. Now since p seems to be all over, that is lowercase p actually, can I write it as cos alpha by a plus sin alpha by b is equal to 1 by p. Similarly, minus sin alpha by a plus cos alpha by b is equal to 1 by q. Now this is our equation first and this is our equation number 2. Now what we will do, we will add up 1 square and 2 square, and we will do it on both left hand side and right hand side. We should be able to get our equation. So let's go to the next step. Let first square the number 1. We will do 1 square plus 2 square. What will happen? We will have cos alpha by a plus sin alpha by b whole square plus minus sin alpha by a plus cos alpha by b whole square, that is nothing but 1 square plus 2 square on the left hand side is equal to, on the right hand side it will be 1 by p square plus 1 by q square. So you can see we already got 1 by p square plus 1 by q square. We will try to simplify on the other side. When you square it, you will have cos square alpha by a square plus sin square alpha by b square, a square plus b square plus 2ab, that is 2 sin alpha cos alpha by ab plus sin square alpha by a square plus cos square alpha by b square. Then next step will be minus 2 sin alpha cos alpha by ab is equal to 1 by p square plus 1 by q square. Now we can see that 2 sin alpha cos alpha by ab, these two will cancel and these two will add up to 1 by a square and these two will add up to 1 by b square. So let's write down the next step. Next step will be, can I say 1 by a square multiply with cos square alpha plus sin square alpha plus 1 by b square into cos square alpha plus sin square alpha is equal to 1 by p square plus 1 by q square. Now we know that cos square alpha plus sin square alpha is 1. Similarly here also cos square alpha plus sin square alpha is 1. So this is nothing but equal to 1 by a square plus 1 by b square equal to 1 by p square plus 1 by q square. That is what we need to prove. So what we have done, let me just try to summarize this. We have been given that line has intercepts of a and b on the axis of coordinate axis. That means when I have x and y like this, the line is somewhere like that. So these are my a comma b intercepts. So I know this is a comma 0, 0 comma b. Now the coordinate axes are rotated by an angle. When they are rotated, now they are telling that the intercepts are p and q. That means this intercept is p and this intercept is q. Now we found out those points, coordinates. What is the coordinate of that 2 points which are intercepting the intercepts on the new coordinate axis? Those coordinate axis, those 2 intercepts coordinates, we found them. That's nothing but, let us say, capital P and here capital Q. We found out what is capital P, what is capital Q. That is, P is P cos alpha, P sin alpha, where alpha is the angle made by the new line with respect, new axis with respect to the old coordinate axis, keeping the origin fixed. We got q equal to minus q sin alpha, q cos alpha. We know from the first line of the problem that line has intercepts a and b on the axis of coordinate axis, that the equation of the line is x by a plus y by b equal to 1. Now these 2 points, whatever we have found, we substituted in the line equation, because those two are also are points on the line, because that's why they are intercepts on the new coordinate axis. So after that we manipulated it, we squared it on both sides, left hand side and right hand side. We simplified it, used a little bit of trigonometric identity, cos square alpha plus sin square alpha equal to 1. We got 1 by a square plus 1 by b square is equal to 1 by p square plus 1 by q square. So that's an interesting example from equation of straight lines. We can do this in so many different ways. We can also do this problem by equating the perpendicular distance, whatever you have, from the origin to the straight line, whatever the perpendicular distance you have with respect to both the coordinate axes, you can do that, and that way also you can prove it. But this seems to be a little bit simpler way of solving it. So I'll catch you once again with another interesting example. Thanks for your time and support. Bye for now.